All right, welcome back to Giving Tuesday live here at BTI, the Boyce Thompson Institute. We are now joined by our next guest, a researcher for both our Klessig and Schroeder labs here at BTI, and also an integral part of a new startup company that kind of came out of BTI called Ascribe. His name is Murli Manohar. Murli, thanks for being here.
Thanks for having me here.
So you may have, if you really follow us closely, you may have heard a recent podcast episode that Murli joined me for and was exceptional on, I may say. So thanks for coming back and doing a camera version.
More fun.
Yeah, is it? Not everyone would agree with you there.
Right, yeah.
So I guess let's start up just telling us a little bit about your background in terms of how you went from kind of a student pursuing science, how you got into science, and how you found your way here to BTI.
Yeah, so I'm originally from India. That's where I born, and I belong to a farmer family. My father, my grandfather was farmers. So I used to go help them in the field, work in the field, see the crop firsthand, diseases and everything firsthand. So, and then I was also interested in like molecular biology in my school. And, India has these schools, they teach you agriculture, and, the part of agriculture is molecular biology and biotechnology. So I chose to go to agricultural college, and where I would learn agriculture as well as molecular biology, biotechnology. And since, like I said, I was farmer family, so I have seen this firsthand, all the problems a farmer would face and all the disease, water shortage and everything. So I was very interested in studying agricultural biotechnology. So I went to a school, I did 4 years of bachelor's in agriculture. And then after agriculture, I learned, farming and everything much better when you go to the school than compared to what you do in the farm, your own farm.
Yeah.
And then after that, I moved to a very nice school in India, Indian Institute of Technology, Roorkee. And that's where I focused on biotechnology, a lot of biotechnology, which has component of both plants as well as animals. So which basically trained you to go wherever you want. They give you exposure to plant science and animal science and other stuff. But since I had a nice agriculture background, plant science background, and then I have exposure there as a plant scientist, plant biotechnology, decided to move on with the plant science as my career. And then I applied in US for PhD. It took me a year, of course, to go through the GRE and TOEFL, and my English was not my first language, so it took me longer than I expected. But finally, I got to Texas A&M University and Baylor College of Medicine. I was a student in both of these campuses. Okay. Because my PI was in Baylor College of Medicine, but that's a medical college, and he works on plant science. He couldn't take a student from there because, the medical college, everybody applied to be a medical student.
Right.
So he has this collaboration with Texas A&M University. So he got me through that. But I worked in Baylor College of Medicine most of my PhD. That's where I did a lot of plant biology, a lot of genetics with yeast. And eventually, like last 3 years of my PhD, I focused on protein biochemistry, where I was trying to crystallize some of the important protein calcium transporters in the plants to understand how they transport calcium and how body, plant as well as human, takes the calcium and use them in their system. So that's my story. And Dan Klessig, actually, we invited him in Texas for a talk. We used to have a MEP symposium. That's my department, Molecular and Environmental Plant Science. He was there. I had a chance to interact with him, and I was very interested in research. And when I graduated, I contacted him, see if he has funding to hire a postdoc. And he said, yeah, why don't you come in? And it happened pretty fast, so I joined in late, I think almost end of 2012.
Okay. So
that's pretty much it.
About 6 years here at
yeah. Time flies. It's, a little over 6 years now.
And you have a family now here in Ithaca?
Yeah, I do. So when I came, me and my wife, and then because, in the PhD, when I was a student, you don't have a good insurance and everything, and my wife didn't have a good insurance. So we couldn't have a family there because of those. And I was busy graduating. When I got married, I graduated a year after. So, there was no point. When I came here, Ithaca is a wonderful place, so many families around, so much help from peers and everybody else. We decided to have family, and my son, Adi, who born here in 2013, November, and he turning tomorrow 5 years old.
Oh, wow.
Yeah.
Well, happy birthday.
Yeah.
So I don't want to do the stereotypical Ithaca conversation, but
Sure.
certainly a bit of a weather
Absolutely.
difference from maybe what you were used to
Oh, yeah.
growing up, and even Texas for that matter.
So Texas was pretty close to where I grew up in India. It's
Okay.
like my place, which is New Delhi and Patna. That's where I born.
Yeah.
It was pretty hot and humid. In centigrade, you get 40, 45, like in summer.
Yeah.
And Texas was no different. The only difference I believe was Texas was much more humid than India.
Oh, okay.
But really, I didn't feel much of a difference. But when I came here, I was excited to see snow. And I was very excited, and I enjoyed first few snows, but then
Yeah.
after that, you know.
Yeah, I was going to say, how exciting is snow now?
Well, it's still exciting somewhat, but not that much. Not anymore, I guess.
So you've been here 6 years. So how would you describe? So as I mentioned, you're kind of split between now Dan Klessig's lab, who you just mentioned, the lab that brought you here, but now you're doing a lot of work for Frank Schroeder's lab.
Mm-hmm.
So how would you kind of summarize what's happening in those two labs? Because I know they're kind of working more closely together now.
Right.
And we can talk about a scribe in a second, but just a general kind of purpose and mission of those labs, how would you summarize those?
So it does seem like I'm working for two labs, but it's really a single project. It's one project. So you have, in Classic Lab, you have expertise in plant pathology. Classic Lab has all the resources you would need to study plant pathogen interactions. On the other hand, Schroeder Lab has expertise in extracting and understanding small molecules from the nature. And this study, this collaborative research, is basically trying to understand how plant in the nature interacts with other organisms using these small molecules. They all have small molecules. They all secrete them outside. And the other organisms, they sense them by these small molecules. So the research we're trying to do is we're just trying to mimic this natural environment where they're all interacting using small molecules. What happens if we take these small molecules from the nature and give the plants in advance and see what happens? Would they still respond the way they respond in the nature? If they do, then we have an advantage. We are preparing the plants in advance to handle the situation that's not there, but it will come. So it's like giving you vaccine, right? I give you vaccine and make you ready for the infection to come, and now you are much more prepared to handle the situations. So it's a single project, and we are using the expertise from both labs to achieve a single goal, same goal.
Because I don't know if everyone realizes how much of our crops, both in the United States and globally, every year, are destroyed by virus, disease, insects, and
About 40%.
about 40%.
About 40%, and if you have severe, so average is 40%, but that's fine. But considering you have all the resources available to protect the crops, but imagine small farmers, in developing countries. It's huge. That's huge, and it's basically they lose everything if the disease is so severe.
And a lot of the work you do, as well as others at BTI, it's essentially how can we cut into that 40% number. But also, by the way, we don't want to do it just by lathering our crops in pesticides, right?
Oh, absolutely, absolutely.
We want to find a way around, drenching food in pesticides. And that's a lot of what you're talking about when you say about essentially giving a vaccine to these crops so that they're ready to handle it, and they don't need it to be sprayed down.
And we're just trying to, actually use their natural immunity. We are just giving them this let's say this our compound as a vaccine, so they're ready. It's a natural stuff, they don't have to, the pesticide or the pathogen won't overcome it because we are not adding anything. And it's a good example. The other day I was listening to this talk in plant pathology, and this professor said, in the rice they're trying to develop a breeding line that could protect them from certain bacteria. And this bacteria is so strong that it overcomes that line, that protection in 5 or 6 years. So basically you do everything, you spend this 10 years getting this line, and then 6 years it will be gone anyway. So the breeding and other approaches, which actually target to kill the pathogens. It's not working. It's clearly not working.
And I think people have come to kind of understand that concept with human disease, right? Like viruses change, and we have to adapt our medicine. And, and we know we kind of know that's how it is, but we maybe don't think about that when it comes to our food.
Right.
Where our food is just as susceptible out there in nature, and that's kind of what you say when you're saying even what we do in the lab. We have to wait and see if that translates when we put it out there.
Absolutely.
It's a whole different kind of ballgame.
Yeah, absolutely. Absolutely. What we do in the lab is everything is controlled.
Right.
Everything is controlled, and you go out, now nothing is controlled.
Yeah.
So, yeah, absolutely. So, I mean, when we talk about Scribe, I'll let you know a little bit about taking our lab work to the field.
Yeah, and this is also, sometimes I think people wonder, why does scientific research take so long sometimes?
Yep.
It's because there's so much of this wait and see, right? You first you have to get it to work in the lab, and then you have to put it outside, at least in terms of crop science, right? You have to put it outside and wait for it to grow and kind of see what happens.
Absolutely.
Once it's outside. So there's a lot of kind of waiting for kind of the life processes to kind of take effect. And so that's why it's not always an instantaneous turnaround.
It's not. Well, you can think, what we do in the lab, you have the perfect light, perfect humidity, perfect amount of water, perfect soil.
Right.
Everything is so perfect. The only thing you have is two components you are testing. One is treatment and one is untreated. So basically you have two factors playing there. In the field, you have another 10,000 factor playing. So you see that if whatever you are testing can overcome all this 10,000, I still give you somewhat similar effect what you see in the greenhouse. 90%, I would say, 95% would fail. It does. So I think, you got to do basic, and then you keep adding factors. You do the growth chamber, then you go to the greenhouse. Greenhouse is a little less controlled. Yep. And then you do a little pilot scale experiment where you still have a nice weather condition and you can control some of it. And then when that's successful, then actually you spread over. Some you send to Florida, some you send to California, some to the Brazil, and see if it's still your product is still viable or the research is still viable.
So one kind of evolution of the research happening here at BTI, and something we'll talk about with guests coming up a little bit later, is the idea that startup companies are starting to emerge from BTI research. There's a couple out there right now, kind of in the early goings. One of them is called Ascribe, which Murli is kind of one of the leaders of. So tell us a little bit about what Ascribe is trying to do as a company, and even kind of the origin story. What led to you and your partners kind of saying we should try to make this a company?
I think before I go to the Scribe, I should thank BTI, because BTI has been very, very helpful. I mean, without their help, we wouldn't be here. We wouldn't have Scribe, and Paul Debbie. He helped every step of the way, and he treated this company like one of his own.
Yeah.
So I think it's one of his own. It's coming from BTI.
Paul Debbie coming up at noon. There's a little plug for you.
Yeah,
wonderful. He'll be on the air at noon.
Yeah,
come on back.
Listen to him. Yeah, he helped all the way, and then of course the whole BTI as a community was very helpful. So we like you said, we were trying to explore this natural interaction of plants with their pathogens, and they interact by using some small chemicals they secrete. And like I said, it's like for plant, if they sense some chemical from some bacteria, and that bacteria is supposed to be a pathogen, then plant sensing this chemical is a red alert for them that this bacteria is around. They got to prepare themselves. But they don't want to prepare themselves too much. If they prepare themselves too much, then they have to basically divert all the resources to prepare themselves, and then the flowering, natural growth, everything suppressed. So what they do is they prepare themselves enough with, it's like a red line. So they just stay below red line. So they're prepared enough, but they don't want to go above red line. So they're happy, they're nice, they're doing everything. There's actually allocated enough resources to be ready, just ready, without affecting anything. And so we just want to take advantage of these chemicals. We identify them from the soil or natural environment and give it to the plant in advance and see if they still consider them as a pathogen coming, and then they prepare themselves, and they do. So we have tested a few chemicals and they do. So they prepare, you give them and they're ready now. And you don't see any effect on their growth and their development. And now you bring the pathogen. 4 weeks after, 8 weeks after, you bring the pathogen. They are still ready and they fight much stronger than the plants were not treated before. So we are just trying to take advantage of this, the naturally abundant chemicals in the soil. I said, like, we identified a few, but we are hoping that there are a few thousands there. Right. So the one of the goal of a scribe is to identify these chemicals and use them to treat crops so they can protect themselves. And there's the first research with one of the compound which is secreted from nematodes, commonly known as roundworm, from soil, and called as kerosites. And we used that chemical, and we did all the experiment I just described. You give the plants in advance, and they, get ready. You bring the pathogen, whatever pathogen, because once they're ready, they're ready.
Right.
So they can protect themselves from many, many pathogens. And so that's the paper we published in 2015. And we thought, hey, in the lab, this seems like very, very efficient in protecting plants from many pathogens. And like I said, we have tested almost 20 different plant pathogen systems, and it worked with all of them. So we used this research, and we thought maybe this is, commercially viable. Huh. And that's when we decided to start a scribe, to take this lab research to the commercial level.
So just to recap, kind of what we're talking about here is you're introducing this to the plant so that the plant can detect this threat that's in the soil earlier.
Right.
So if you're a gardener, you may be familiar with nematodes destroying your stuff, right?
Yeah,
destroying your crops. So essentially when these are in the soil, and to date maybe they sneak up on a lot of the plants sooner than the plant would like, and the plant's not ready to defend itself, what you're doing is you're giving it a head start.
Head start.
Yeah.
Absolutely. That's the best way to put it. Yeah.
So, well, that's great. So you've been out on the road a little bit, kind of pitching this company and presenting what you're trying to do and trying to bring in some funding. How's that gone for you? Where have you gone? And what has kind of been the reaction to what you're trying to do?
Yeah. So the research is very exciting, and I think I went to present in North Carolina. A conference is basically where you have all the investors coming together to listen to the new technology. They were all very excited, and we got in touch with most of them. And actually, we are talking to one of them. So we spoke to them before, but they wanted some more results, more results before they actually make any commitments. So I'm talking to one at 3 p.m. today.
Okay.
And see how it goes. And then, of course, then we also had chance to, present other places, meet other people, use all the resources possible to get to the investors. And Jay Farmer, our CEO, Scribe, he's also trying to reach out to several investors and trying to get money. That's the investor part. And then there's U.S. government offer this startup seed money, like NSF does, USDA does, NIH does. And our product our research is suitable for both NSF and USDA. So we applied for NSF last year. It came back pretty nice, and they asked us about more results, which we put together and submitted again. And yesterday, actually, I heard that they recommended our award. So it's in administrative processes. So it might take another few weeks before I actually get the money, get the award. So when that happens, we'll kind of celebrate.
Yeah. Oh, that's great.
And in the meantime, we also applied for USDA.
Okay.
So we just you have like so many pathogens and so many plants. So the NSF was focused on particular aspect of the plant pathogen, and then USDA is focused on something else. So we have these two awarded this time. So NSF is, I guess, almost done. USDA will probably hear in another 2 months.
Great. Well, do you find yourself at times thinking, I'm a scientist, but all of a sudden I feel like I'm more of a business entrepreneur out there, like trying to work around the business aspects of of creating this company?
It's a good language to learn, right? Business people speak a different language. And I think Jay Farmer, CEO, our CEO, he's very helpful. He taught me all this stuff. And there's one thing, it's called, NSF offered this course, Innovation Corps. And it's a local course. So basically NSF has this local domain, like in Cornell has one, Rochester has other one. So we applied for that, and I got in there, and it was like 2 weeks course. Oh my God, it was very nice course, amazing. So they'll teach you how to comfortably talk to your customers. So, it was very interactive course. It's not like I'm sitting there and listening to the talk. No, basically they're asking you questions. They're asking you to stand up and present like you're presenting to customers. So that was very helpful. And then they also give you funding, which I will be applying soon to visit to your customers. Like if, for example, if eventually we think then Monsanto will buy our company or Bayer will buy our company, then they'll give us money, NSF will give us money to go talk to them, to go understand what they need and how you can modify or modulate your product so they can be interested in you. So I applied for the first round, which is little money, so I can go to 1 or 2 company. But if I meet their guideline or their requirement, then they'll give me a second round, which is very competitive, but about 50,000, I guess. And then you go to 20 different places. You understand your customers, and then you modify your products. So it's to make it more suitable for wherever you're going, whatever crop you need to.
Well, great. And now I'm going to end with the non-science question, giving everybody, and that's when you aren't doing scientific research, what are your hobbies, your go-to outside of work kind of activities that you're really passionate about?
Well, I was very passionate about cricket, which is a nice game in subcontinent. But after my son was born, so I think he became my part-time entertainment.
They will do that.
Yeah. So I spent some time with him, and if I still find some time, then I go to Netflix. All these new shows, they have like Narcos and stuff. I love them.
Narcos is a good one.
Yeah, it's
a kind of addicting show.
Yeah, addicting show, yeah. So, I spend some time with that if I find time after, research and the company and everything.
You like getting around Ithaca when the weather's a little more pleasant?
Oh, even in the winter. Even in the winter.
That's true, yeah. There's plenty of winter outdoor fun.
Yeah. So I'm planning to go to Niagara Fall. Christmas.
Oh, okay.
It's a different, if you go in the summer, if you go in the winter, it's different. So the Ithaca overall is a really nice place to work, live, and raise your children. So I think it's a beautiful place. And I'm glad that the company is coming through. I might have chance to stay here longer than I anticipated.
Great.
Last year I thought maybe I apply for faculty position and leave soon. But things have changed now. I'm staying for at least another year or 2.
Yeah.
Put the company on the feet, and if everything goes well, then maybe company don't need me. Everything is set. Then I can go explore my own, future.
Well, we want you here as long as you're willing to stay. What am I going to do? Who am I going to talk to if you leave?
Damn.
Our next guests that are just arriving. Well, thank you very much, Murli.
Thank you.
This is Murli Manohar. His company is a Scribe, and if you're a big investor out there, look him up. If you're a smaller investor, you can engage in Giving Tuesday on behalf of BTI.
Yeah.
BTIscience.org/give is where the smaller investments, or larger, we can handle larger payments if you're so inclined. But look up Murli. He's doing incredible work with the Klessig and Schroeder Labs, and really impressive stuff. And we're really proud of everything you've done and how you've advanced the mission here at BTI over the last 6 years. And happy birthday
to my son.
To your son.
Yeah, thank you.
All right, we'll be back in just a few minutes with John Ramsey and Andy Cruz.
Thank you.